Hello friends, today we are going to talk on receiver operating characteristic or ROC curve. The ROC curve was first developed by electrical engineers and radar engineers during World War II for detecting enemy objects in battlefields starting in 1941, which led to, to its name receiver operating characteristic. It was so introduced to psychology to account for the perceptual detection of stimuli. ROC analysis has been used in medicine, radiology, biometrics, forecasting of natural hazards, meteorology, model performance assessment, and other areas for many decades and is increasingly used in machine learning and data mining research. The basic concept: suppose we have a binary classification problem where you have two classes, positive and negative. Given the experiment data or the survey, we estimate the probability of the positive class. We set a threshold value between 0 to 1. If the estimated probability is bigger than the threshold value, we predict positive class, otherwise we predict negative class. So that's binary prediction or binary classification. Classify the output as being positive or negative. There are four classes involved. Actually, the value could be positive or negative, and we are predicting positive or negative. So 2 into 2, 4 values. The four classes are true positive when we predict positive class correctly, false positive when we predict positive class wrongly, true negative when we predict negative class correctly, false negative when we predict negative class wrongly. So prediction can go right or wrong, and the actual class could be positive or negative. So that is 2 into 2, 4 classes. Here is a graphical description. We have predicted positive, predicted negative, and actual condition positive or negative. So we have true positive, false negative. We have predicted negative falsely. Then false positive and true negative. Then we calculate the true positive rate, false positive rate, and accuracy comes as the proportion of correct predictions. Accuracy of the classifier is defined as the proportion of true positive plus true negative cases, or the proportion of correct predictions when the prediction is true. True positive rate is defined by TP plus Fn. True positive by true positive plus false negative. So when we are predicting positive class, how many times we are correct? So that is true positive rate. Then we have false positive rate, which is Fp by Fp plus Tn. False positive by false positive by plus true negative. So we are predicting negative. So this is the probability of wrong negative predictions, which is false positive rate. So we draw the ROC curve. The ROC curve plots false positive rates in x-axis and true positive rates in y-axis for different threshold values. So we have false positive rates in x-axis and true positive rates in y-axis. And this dashed line is the random classifier where the being positive, predicting being correct or wrong is only is both ways 50%, and these are the ROC curve where we plot the false positive and true positive pairs, And the area under the curve gives us the idea about the performance of the classifier. Bigger is the area, better is the performance. Higher is the area under the curve and the 45-degree line, the better is the performance of the classifier. Sometimes the ROC is used to generate a summary statistic. The intercept of our ROC curve with the line at 45 degrees orthogonal to no discrimination line, the balance point where sensitivity equal to specificity. These are different interpretations, different concepts based on the confusion matrix, true, false, positive, negative. The intercept of the ROC curve with the tangent at 45 degrees parallel to the no discrimination line that is closest to the error-free point 0,1, also called Jordan's J statistic and generalized as informedness. This is another concept, informedness. The area between the ROC curve and the no discrimination line multiplied by 2 and subtraction of 1 is called the Gini coefficient, especially in the context of credit scoring. In the context of credit scoring, we use Gini coefficient. It should not be confused with the measure of statistical dispersion, also known as Gini coefficient. However, any attempt to summarize the ROC curve into a single number loses information about the pattern of trade-offs of the particular discriminator algorithm. So, to measure the performance of the classifier, we need the whole of ROC curve, and attempts have been made to come up with a single number like a F1 score, etc. But we are losing information. There is no number that can replace ROC curve. I'll stop here. The entire talk is based on the Wikipedia article. Like, comment, share, subscribe my video. I am available for one-to-one sessions too. Thank you.